What up, what up? I'm the math teacher Goat, and today in AP Precalculus we are doing 2.12 Logarithmic Function Manipulation. This is one of my personal favorites. I love logs, always have. That's why I'm a big fan of cabins. But this particular section where we do all these rules, I love it. I don't know what's wrong with me. Go to the description, download the notes, please. Like and subscribe, please. Leave a comment how much you love me. Let's get right into it once this thing loads. And there we are. Warm up based off of what you saw in the previous lesson. You're given g of x equals 0.5 log x minus 2. Now, we need to see which of the following transformations takes place here. Now, when we take a look at these, right, anytime you have a number multiplied to the log, if you remember from yesterday, that was a vertical dilation of a kind. We're not doing anything inside the x, so we're not going to move left or right, which would be our horizontal translation. But out here, we're subtracting 2, which is a vertical translation. So we're going to move down, and this is going to appear to flatten out faster. Even though it never flattens out, it flattens out faster. So we would say that this is a vertical dilation of a half and a vertical translation of -2 or 2 units down, which not a horizontal dilation, a vertical dilation, yup, not you and not you. All right, stuff we did in the previous lesson, fun, 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 fun in the sun. Here are the rules of logarithms. Now, the main ones that we're going to focus on today are going to be rules 1, 2, and 3. Rules 1, 2, and 3 state, and usually we go backwards, so this would be me expanding it. We're going to start out by simplifying it, so when we write out these rules, we're kind of going with the simplifying route. If I give you 2 logs of the same base and you're adding them, what you do is you multiply the insides. Multiply, that's an I, the insides. So simplifying into 1 log would have me going from this guy to that guy. Expanding it would have me go from left to right. Similarly, rule 2 of these logs is if I were to simplify into 1 log, whenever you subtract logs of the same base, you divide the insides in that order. In that order. So it's not going to be n over m, it's going to be m over n. Similarly, if we were to expand this, if we see log base b of m over n, that must have meant that we subtracted in the first place to get us to that point. Rule 3 says that if I have a coefficient in front of log, we're allowed to make it an exponent inside the log. So this turns into that when simplifying into 1 log. Expanding this would have me ripping the k out. So I have, if a log has a coefficient, make it an exponent. Make it an exponent. All right. Oh, by the way, before we even go any further, these are just some other rules. We talked about these 2 rules in the previous lesson. Rule 4 is log base b of 1 equals 0. And if you're wondering why, if you were to write that out in its exponential form, okay, basically you're saying b to the 0th equals 1. Anything to the 0th, as long as it's not 0, equals 1. And you're not allowed to have a base of 0. So, so in reverse, log base 1 of anything, or log any base of 1, is just going to be 0. And similarly here, if this kind of comes from rule 6. If you were to put an invisible 1 there, right, then these guys would cross out and then the 1 just drops down. So a bunch of rules that we're going to have to remember, a bunch of rules that we're going to have to remember. Now let's combine them into one single logarithmic function. Log base 3 of x minus log base 3 of y. If you subtract logs of the same base, divide the insides, and this gives you log base 3 of x over y. Like that. Now, if we're going to combine this into 1 logarithm, what we're going to want to do first is turn these into exponents first. So bring the 2 up, bring the 3 up. That gives us ln of x squared plus ln of y cubed. And if you're like, wait a minute, that's an ln, not a log. Homie, ln is log base e. Watch my last video. Now that we add logs of the same base, or we add ln's, we multiply the insides because ln's behave like logs. So that's our guy. See how much fun this is? All right. So you're going to want to deal with exponents first. In this case, the exponent's already taken care of. Now we're going left to right. Okay, so if you were to combine these guys, when you subtract logs of the same base, divide in order. So this becomes log base 5 of x squared over y plus log base 5 of z. Now we're adding logs of the same base, so multiply. So that z lives with the x squared because it's technically in the numerator. And this becomes log base 5 of x squared z over y. Okay, this is very similar, except now we have the 2 living on the outside, so let's deal with the exponents first. So this becomes log base b of x minus log base b of y squared plus log base b of z. Left to right, log base b of x minus log base b of y squared has you dividing the logs, or the insides rather. So log base b of x over y squared. And then we still have plus log base b of z living there. And when you have logs of the same base and you're adding, remember that z, just like this one, goes to the top, and you're left with log base b of xz over y squared. Bada bing! Let's make it multiple choice. Let's change up these colors. Bland. All right. First thing that we're going to want to do is we're going to want to move the exponents up here, because when we simplify, we move the coefficients into exponents. That gives us log base 4 of a cubed minus, bring the half up, log base 4 of b to the 1/2. Now, b to the 1/2 can be written as the square root of b. So let's do that quick. We have log base 4 of a cubed minus that. When you subtract logs of the same base, you divide in that order. So this finally becomes log base 4 of a cubed over the square root of b, which is that. And that, oh no, it was a trick problem. Remember, b to the 1/2 is the square root of b. Remember when we did that? Well, we have to do the same thing in reverse. So my own problem nearly goofed me. Nearly got it. But it didn't get me. Only one person can trick my, well, 2 people can trick me, Satan, and another person is me. But we will not allow either of those to trick us no more. Amen? Type amen in the comments. Type amen if you agree. That reminds me of all of my Christian Facebook posts. First thing that we're going to want to do is we're going to want to put that to the 1/3 there. So log base 2 of x doesn't change. Now you're plus log base 2 of y to the 1/3 minus log base 2 of z, squishing that in. It looks like they don't want me to turn that into a cube root, so I will not turn it into a cube root. I'll let it go. Working left to right, we're going to combine these two. So log base 2 of x plus log base 2 of y to the 1/3 is going to be log base 2 of xy to the 1/3 minus log base 2 of z. When you subtract logs of the same base, that's log base 2. Let me see, you divide x, y to the 1/3 over z. And that would be a. So that's simplifying into one single logarithm. Let's expand the logarithm, which means we're going to go in reverse. We're going to ask ourselves what must have happened to get us to this point. If you notice, what we dealt with first is when we did the previous problems, is we dealt with the exponent stuff, okay, turning the coefficient into the exponent. That's the first thing that we would do. And then we would go left to right. Okay. Now what we're going to do is we're going to reverse that. We're going to go, why don't we split, step number one, we're going to split division stuff. Then we're going to split the multiplication stuff, and then we'll bring the exponents out in that order. Opposite of what we just did. So there's no division to deal with, so let's split the multiplication. So if we had log base 3 of 5x, that must have meant that we did this first. Log base 3 of 5 plus log base 3 of x. And when we're done that, there's no exponents to deal with. We're done, easy peasy. With u, we're going to split the division first. So this is going to be log base 5 of x squared minus log base 5 of y cubed z. Now be very, very, very careful. When we split up the multiplication part, that negative applies to that whole log. So when we split this up, this becomes minus parentheses log base 5 of y cubed plus log base 5 of z. Which then turns into log base 5 of x squared minus log base 5 of y cubed minus log base 5 of z. Now to wrap this up, let's bring the 2 and the 3 out. So 2 log base 5 of x minus 3 log base 5 of y minus log base 5 of z. How in the world I'm going to do these with the space that I gave myself? We'll see. We'll see what happens. All right, no division to worry about, so let's just split them all up. So we'll fit it in there. Log base b of x plus log base b of y squared plus log base b of z cubed. Let's bring the exponents out. Bring you out front. Bring you out front. That gives you log base b of x plus 2 log base b of y plus 3 log base b of z. Okay. Last one on this page, same exact conundrum that I gave myself. We got to do the division stuff first. So ln of a to the 5th minus ln of b squared c. All right. Now we need to split that up and keep it in a set of parentheses or brackets. ln of a to the 5th minus ln of b squared plus ln of c. That becomes ln of a to the 5th minus ln of b squared minus ln of c. And after we bring the 5 out front and the 5 out front, that gives us 5 ln of a minus 2 ln of b minus ln of c. Did it seriously give me 2 of the same option? Oh my gosh, I did seriously do that. Doy. All right, why did I do that? No, I didn't. Ah! I leave my mistakes here on purpose because it's important to realize that although I'm close, I'm not perfect. And I do make mistakes, and a lot of people will comment on my videos saying, you messed that up, and that's fine. I'm human. I'm going to mess things up. All right. Something that's not used as often but can be used is the change of base formula. Now, in the last section, I believe it was the last section, when we were graphing, I showed you how to use like the change of base or a special log base thing when you plug it into your calculator, and you could do that here. Okay, but the change of base formula for logarithms allows you to rewrite a logarithm in terms of logs with the same base. So if I give you something like this, okay, log base b of x, you could write it out as log of whatever x over log of whatever b. And usually what I do with a case like this is when I see this, I write it out in two different ways. Okay, log of 43, I just leave it as log over log of 5. Or you can write it out as ln of 43 over ln of 5. It's all good. And again, if you're using like a regular calculator, this is how you could do problems like this. The TI-84 Plus gives you a button that I think it looks like this. I think it's, I don't know if the caps are right, but it looks like that. You type out math, you go up a few times, and so when you do that, it gives you like a little button that highlights like that and a little thing that highlights like that, and you could type it in yourself and plug it into the calculator the way you need to. Okay, so when we see a guy like that, write it out as either of these, okay? Log of 101, my favorite amount of Dalmatians, over log of 4. Or you could type out ln of 101 over ln of 4. I could, if I wanted to, I can make this log of 67 of 101 over log 67 of 4. It doesn't really matter as long as I choose the same base. Now, this would be a waste of time if I were to try to do this in my calculator, but if someone's like, you could write it any way you want, then technically I can write it out like that. So I'm gonna. And I think that'll appear in a later problem. We'll see. And that might be right now. A function f is given by f of x equals log base 3 of x. Which of the following is equivalent to f of 9? All right, so log base 3 of 9 is what they're asking for. So they want me to do the change of base formula. So this is going to look like log base whatever of 9 over log, by the way, the answer to that's 2. Log base whatever of 3, which is not u. U are upside down. Where did that 10 come from? Now this seems pointless, and it is pointless, but technically that's correct. I can write that out as log base 9 of 9 over log base 9 of 3. I'm allowed to do that given the rules that I have. Would that help me in a calculator? No. I do know that log base 9 of 9 is 1. So, I mean, remember up there when I said that the answer is 2? So technically this would be 1 over 1/2. Because you're basically saying, and 9 to the what power is 3? Well, the square root of 9 is 3, so 9 to the 1/2 is 3. And 1 over 1/2 means just multiply the top and the bottom by 2 over 1 to cancel those guys out. And 1 times 2 over 1 is 2. But that's just extra fluff that I'm just adding to make these videos longer. Just giving you more knowledge. The answer is D. Leave it at that. The function g is given by g of x equals log base 5 of x, and the function h is given by log base 25 of x. Which of the following describes the relationship between g and h? All right. Well, looks like we should probably write these out in their other form. I don't know. That's just where my head's going. So g of x, if I were to write that out, well, actually, no. Let's do this. Let's write h because that 25 and that 5 are related. So let's write h out using the change of base formula. Okay, so if I have h of x, okay, which is log base 25 of x, I can write that out as log. Let's do this. Let's do what we saw up there. Log base 5 of x over log base 5 of 25. Now, log base 5 of x is the same as g of x. So this is the same as g of x. Log base 5 of 25 asks you the question, 5 to the what power is 25? 5 squared. So we could say that h of x is half of g of x. H of x is half of g of x. So for equal input values, the output values of h are half the input of g? Yup. The answer is A. Really strange problem. One of those AP pre-calculus problems that would show up on the exam and kids who get 5s would get something like that right. Very tricky. Very, very, very tricky. The function f is given by f of x equals log base 5 of 3. The function g is given by g of x equals log base 5 of 3 to the 4th. Which of the following describes a transformation? All right. So this is obviously what we have to do. Okay, and by the way, we're transforming f into g. So why don't I take g and move that forward? And so now g of x is 4 times log base 5 of 3. We know from the warm-up that this is a vertical dilation by a factor of 4 because 4 is being multiplied to log base 5 of 3. And so B is going to be our answer. Nothing crazy, nothing crazy, nothing crazy. This, we're just ending, oh nope, we got 2 more, but we're almost ending with a bang. Very unpleasant problem. But I like it. I like these. They're not that bad. They're really not that bad. It's just you have stuff in parentheses, so leave the stuff inside the parentheses. Who cares? And then your job is to find out which one of these is false. So let's do the bare bones basics first. Let's start out by moving that 2 up there. So now we have log base 3 of x plus 3 plus log base 3 of x minus 1 squared minus log base 3 of x plus 2. Now that we're adding them, let's multiply the inside. So we're going to need a big parentheses for this. Log base 3 parentheses parentheses x plus 3, close it, open it, x minus 1 squared, close it, minus log base 3 of x plus 2. Subtracting logs of the same base means that we keep these guys in the numerator, so log base 3, big parentheses, of x plus 3, x minus 1 squared, all over x plus 2. So I need the lie. So let me see, x plus 3, x minus 1, and x minus 1, and x plus 2. So let me see if I can find the original u. Okay, so since you're true, that's not an option. I could split x minus 1 up into 2 factors, so since you're true, you're not an option. Looks like that could be the FOILed version of that. So if I were to FOIL x minus 1 squared, that's a difference of squares trinomial, or a perfect square trinomial, not difference of squares, perfect of square trinomial. So that's x squared minus 2x plus 1, which is that. So you're true. And that guy just has a random 2 living out front. Now, they want you to think that it's okay to move that out front. Nope, if you were going to move that out front, you can't even do that because that 2 is not attached to everything. So this is just a lie, which means that's the one we want. And then last but not least, we have a friendly, 2 more. Boy, am I way off today. So remember, ln's behave the same way as logs. So I could bring u up here, and I could bring u up here. So that gets me ln of e to the 4th plus ln of e to the 3rd minus ln of e squared squared, which is e to the 4th. Now watch. Okay, ln is the same as log base e. So if I were to take the ln of e to the fourth, log base e of e to the fourth cancels out. ln and e cancel each other out, bringing down a 4. ln and e cancel each other out, bringing down the 3. ln and e cancel each other out, bringing down minus 4. You guys cancel out, leaving me with just a 3. The answer is C. Ooh, tricky, 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 but I love it. All right, one last one. Finally, the last one. Let's move that 5 up here. Let's do the same thing with 6. This is regular log, so we can combine them. So that's log x to the 5th plus log y to the 6th. When you multiply logs or add logs of the same base, multiply the insides, which makes it look like u. All right? So that's that. Make sure you type out, what is that, 2.11? Is that what this is? Let me look. No, 2.12. Make sure you go search in my YouTube, AP Precalculus 2.12 to see some of my other random videos that might be helpful for you. It'll do you some good. And that's that. Like and subscribe, leave a comment, all that good stuff. Thanks for watching. Watch my other videos. Bye.